Okay, we're going to do just some problems from your worksheet that I handed you. And we're going to introduce some new terms, and they're really not new, but we're going to be looking at graphs, and we're going to find their x and y intercepts. We're going to find where they have a relative max and min, and then we're going to find where they have intervals of increasing or decreasing. And then we're going to talk about their end behavior and write down their domain and range. Okay, so on number one, that's the first one we're going to do together. The very first thing we're going to do is find the x-intercept. So I'm going to look at my graph and I'm just going to write down in the blank where my graph crosses the x-axis. So I know it crosses at -4, this point right here. It crosses at 2, and then it crosses at 5. So we know our x-intercepts. Then it asks for our y-intercept. Our y-intercept is where it crosses the y-axis, and that's 2. And now we're going to write down where a max occurs. When we write down where a maximum occurs, we're going to write down the x value at which it occurs. So I have a local max right here. So I'm going to say I have a local max at x equals, and what is the x value that local max occurs? Well, it's at x equals -2. Okay, so I have a local max at x equals -2. Now, if it said what is the maximum value, then we would say 4. But anytime it asks you to identify where you have a max or a min, you always put its x value. So now we're going to find our local min. Well, here's our local min, and it occurs when x equals 4. Okay, now we want to write where this function is increasing or decreasing. All right, so let's do increasing first. So it's going to be increasing where it has a positive slope, okay, or where my graph is rising from left to right. So do you see it's rising right here? It has a positive slope, and also right here. Well, when we write where it's increasing, we're going to write it as in interval notation, so it's going to be in parentheses. And we use only our x values. So do you see that this, we're going to assume, has arrows at the end? So my x value, it's going to start from -infinity, and it's going to stop at this point when x equals -2. Unioned with, now I need to find the interval, my other interval where it's increasing. Well, it starts when x is 4, and then it keeps on going. So it's going to be 4 to infinity. Okay, so now let's do where it's decreasing. So it's going to be decreasing from here to here. Well, my x value at that point is -2. It's not showing up very well. That's okay. And it goes until x equals 4. That's where my graph is decreasing. Now, when it says where is it constant, constant just means that the slope never changes. So if I had something like this part right here is constant. So we don't have any constant intervals in this. Okay, and again, we know this is increasing because the slope was positive. We know that this is decreasing because my slope was negative. My domain, so my domain for this problem is how far to the left and how far to the right does this graph go? Well, all reals. Or we could write -infinity to infinity. And then it says how far, for our range, that means how far up, how far down does this go? Well, again, if we assume that it goes all the way down and all the way up, the range would be all reals. Or I could write that -infinity to infinity. Okay, now we want to describe its end behavior. Okay, and this is how we wrote it in class. So as x approaches infinity, what does f of x do? So as x approaches infinity, so they're talking about the right-hand side of my graph, what are my y values doing? Well, they're approaching positive infinity. As x approaches negative infinity, so they're talking about the left-hand side of my graph, what are my y values doing? They're approaching negative infinity because they're going down. Okay, so that's how you're going to do problems 1, 2, and 3. And let's look at number 4. Number 4, same type of thing. Let's find our x-intercepts first. So our x-intercepts is where it crosses the x-axis. So that's going to be at 2, and that's a little bit past 5, like 5 1/3, something like that. So I'm going to say 5.3 or 5.25, somewhere a little bit past 5. My y-intercept is -2. Now let's find its max, okay? I want to find a local max. Well, first of all, this is going to keep on going up. So I don't have a local max there. I have a high point here, but do you see it's an open circle? So that's not going to be included. And it's an open circle here, so I can't include that. So this problem is not going to have a max. There is none. My min, okay, a local min, I can't count this point because it's an open circle. I can't count this point because it's an open circle, but I can count this, okay? And remember, when I list my max and min, I'm listing the x values. So I have a local min at x equals 4. So that x value. Okay. Now we want to state the interval where it's going to be increasing. So it's increasing where the slope is positive. So my slope is positive from here to here and from here to here. So when I list those intervals, I list their x values. So it starts at -1 and it goes to 4, and then it has to stop because it has a break. Unioned with, this point starts up with 4, and it's going to go to 6. Okay, now let's find where it's decreasing. So it's going to be decreasing right here because I have a negative slope and my graph is falling. So how far to the left does that go? That goes from negative infinity because of my x values until I get to when x is -1. I don't have any constant intervals. My domain for this problem, my domain is going to be where do I have x values? Okay, well I know from the left it goes from negative infinity until I get to -1, unioned with -1 to 4, unioned with 4 to 6. I'm going to change this to a bracket right here because this 4, that closed dot, was included. Now my range are my y values. How far up and how far down does this graph go? Well, I can use my max and min in order to do that. Okay, my range, well, I said I can use my maxes and min. We're going to see how far down does this graph go. Well, it goes down to -3, and for range, we're using our y values. So it goes to -3, but it's going to be a parentheses because it doesn't include -3. And then how far up does this graph go? Well, it includes all my y values up to positive infinity because it goes all the way up right here. So my range is -3 to infinity. Okay, as x goes to infinity, so I'm looking at the right-hand side of my graph. As I go to the right-hand side of my graph, as x goes to infinity, where do my y values go? Well, you see that it stops right here? So I don't know where it goes. I can't say as x approaches infinity what my graph does. So I'm just going to put a dash, or you can put not possible, or not possible would work. As x goes to negative infinity, so as x goes to negative infinity, that I'm talking about the left-hand side of my graph, it approaches positive infinity. Okay, so let's look on the next page. Use the given graph for the function f. So is f increasing on the interval from -8 to -2? So here's -8, here's -2. So I'm going to trace it. Is that part of my graph increasing? Okay, and it is, yes, it is increasing. Is f increasing on the interval from 2 to, what's it say, 10? So from 2 until I get to my x value 10. Is it increasing on that whole interval? No, because this part right here is decreasing. So now it says list the intervals on which f is increasing and justify your answer. So I'm going to erase this part, and I'm going to highlight the part that's increasing. So we know it's increasing from here to here, from here to here, and from here to here. Okay, so it starts at -8 and goes until my x value of -2, unioned with 0 until 2. Remember, we're using our x values. Unioned with 5 to infinity. And then it says justify your answer. Well, we know it's increasing because its slope is positive. Okay? I know it's because my slope, if I had to draw, and later in calculus and pre-calculus you'll learn about drawing tangent lines, but the slope of the tangent line at those points is positive. But right now we're just going to say because slope is positive. Now we're going to list the intervals on which f is decreasing. So I know it's decreasing from here to here, from here to here, and here to here. So it's decreasing, remember we're using x values, from negative infinity until I get to -8, because we're going to assume that that's an arrow. So negative infinity to -8, unioned with, from here to here, that would be -2 to 0, unioned with, from here to here, that's going to be from 2 to 5. And we know that because the slope of the tangent line, or because the slope is negative. 5 says list the values of x at which f has a local max. Okay, so I have a local max right here and right here. So when x equals -2 and x equals +2. And I know that because if I had to draw one line, this is what's called a tangent line, and all maxes and mins have a horizontal tangent line. Or if I had a board and I had to set it on top of a max or min, that board would sit flat as a slope of 0 at that point. Okay, now let's find our local min. Okay, I have a local min here, here, and here. So when x equals -8, 0, and 5. And then we're going to list our x-intercepts. It crosses here, 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 and at 5. So -10, -5, 0, 5. The y-intercept, it crosses the y-axis at 0. Okay, and the last type of problem. Problems 9 through 12 state its domain and range, the x and y intercepts, the intervals of increasing, decreasing, and constant. So let's do part A. The domain for this. The domain is how far left, how far right does this graph go? Okay, well, this graph does not have arrows, so it starts at -4 and ends at 4. So my domain is from -4 to 4. Another way to write it, sometimes we see it written like this. Set of all x's such that -4 is less than or equal to x is less than or equal to 4. My range, how far up, how far down does this go? Well, my lowest point is at 0 because range are y values. My highest point is 3. So I could write 0 to 3. And going back, since these points are included, they're closed circles, I need to put brackets around here instead of parentheses. Same thing here, brackets from 0 to 3. Or I could write all y's such that 0 is less than or equal to y is less than or equal to 3. Okay, part B. My x-intercepts, -2 and 2. My y-intercepts, it crosses my y-axis at 3. Okay, part C, intervals of increasing. So this is increasing from here to here and from here to here. So it's increasing from -2 to 0, unioned with 2 to 4, because the slope is positive. Now, I know these are closed circles, so when we write intervals of increasing and decreasing, we're always going to write parentheses around that. Okay, you don't have to worry about whether it's parentheses or bracket. Part D, I want to write the intervals where it's decreasing. So it's decreasing from here to here and from here to here. So it's decreasing from -4 to -2, unioned with 0 to 2, because the slope is negative. And it says part E, intervals of constant. I don't have any constant intervals. I don't have any just straight horizontal lines. So none. Okay, so you have examples of each type of problem on your worksheet, and you will finish those up.